In this video, we will understand and implement recursive binary search algorithm in JavaScript. Let's start by understanding the binary search algorithm. Binary search algorithm is used to find a specific element in a sorted array or list by repeatedly dividing the search interval in half. It compares the target value with the middle element of the array and decides to continue searching in the left or right half, narrowing down the search range by half each time. Let's understand two types of approaches. Iterative and recursive are two approaches to solve problems in programming. Number one, iterative approach involves loops like for or while to repeat a set of instructions, while recursive approach involves a function calling itself to solve a smaller instance of the same problem. Number two, iterative approach uses a sequence of statements that are executed repeatedly until a certain condition is met, while recursive approach breaks down a problem into smaller subproblems and solves them recursively, means function calls itself. Number 3. Generally, iterative approach involves a state or variable that is updated in each iteration until the condition is false, while recursive approach requires a base case to prevent infinite recursion and define the termination condition. Let's implement with step-by-step explanation with first method, which is recursive method. First step is function declaration. Let's declare a function called binary search recursive. This function binary search recursive will take 4 parameters. First parameter is an array ARR in which the binary search will be performed. Second parameter is target. Target is the value searched for the array. Third parameter is start. Start is the starting index for the search. Its default value is 0. Fourth parameter is end. End is the ending index for the search and its default value is arr.length minus 1. Because array indices starts from 0 and the index of the last element is n minus 1. So the end value will be arr.length minus 1. So we will write function binary search recursive within bracket first parameter arr, comma second parameter target, comma third parameter start equal to 0 and the last parameter, which is fourth parameter, and equal to arr dot length minus 1. After that, curly braces. Second step is base case. Base case of the recursion is that the function, which is binary search recursive function, checks whether the start index is greater than the end index. If the start index, which we will represent by start, is greater than the end index, which we will represent with end, it means the search space has become invalid and the target cannot be in the array. In such a case, the function returns minus 1. So we will write if start greater than end, after that return minus 1. Third step is recursive case. If the base case is not met, that is start is not greater than end, then the function binary search recursive proceeds with the recursive binary search. In recursive binary search, we calculate the middle index of the current subarray, that is start plus end by 2. Here we will use a JavaScript function math.floor. This function math.floor rounds down to the nearest integer. Here we will represent middle index with a variable named mid. So we will write const mid equal to math.floor start plus end by 2. Fourth step is comparison with target. In this step, we will compare the value of the middle index, that is arr mid, with the target value. There are 3 cases in this step. Case number 1. If the middle index arr mid and the target value are equal, then the target is found and the middle index is returned. In this case, we will use if statement. So we will write if arr mid 3 times equal to sign target. After that, we will return mid. Second case is if middle index is less than the target. The search is narrowed to the right half of the array. because the array is sorted in ascending order in a typical binary search. In this case, we will use else if statement. In else if statement, if the condition in the first if statement is not true, the code proceeds to the else if statement. Here, condition in the first if statement was that middle element is not equal to the target. So now we will proceed to else if statement, and we will write else if array mid less than target. In this case, we will make a recursive call to the binary search recursive function. Recursive call means that the function binary search recursive will call itself, and the parameters will be updated to search in the right half of the current subarray. The parameters passed to the recursive call are as follows. First parameter is ARR. ARR is the same array being searched. Second parameter is target, and target is the value being sought. Third parameter is mid plus 1. Mid plus 1 is the updated starting index for the new search. It is set to one position to the right of the current middle index, so we will write mid plus 1. Fourth parameter is AND. AND is the ending index remains the same, defining the right half of the current subarray. So we will write return binary search recursive ARR, target, mid plus 1, AND. Third case is if ARR mid is greater than the target, the search is narrowed to the left half of the array. In this case, we will write else block, and this else block is associated with the else if statement, that is ARR mid less than target condition. Now again, return statement calls the binary search recursive function recursively, initiating a new search in the left half of the current subarray. The parameters passed to the recursive call are as follows. First parameter is ARR. It is the same array being searched. Second parameter is target. Target is the value being sought. Third parameter is start. The starting index for the new search remains the same, defining the left half of the current subarray. And fourth parameter is mid minus 1. Mid minus 1 is the updated ending index for the new search. It will be set to one position to the left of the current middle index. So we will write return binary search recursive ARR, target, start, mid minus 1. Let's take an example to understand binary search recursive algorithm. Suppose we have a sorted array which have elements 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we will write const sorted array equal to within square bracket all the elements 1 to 10. And we want to find the index of element 7. So we will assign a new variable target element, which value will be 7. So we will write const target element equal to 7. Here we will introduce a new variable result, which will store the value of binary search recursive, and we will pass two arguments to this function binary search recursive. First argument is a sorted array and second argument is target element. So we will write const result equal to binary search recursive within bracket sorted array, target element. Now we will use conditional statement if else to check whether target element value is found or not. If results value is not equal to -1, then if block will execute. Then we will write if result does not equal to -1, after that curly braces. We will write console.log to print a message indicating that target element is found in the array using string interpolation. For string interpolation, first we will write backtick, then after that we will write element, then dollar symbol, then curly braces. Within curly braces we will write target element, then curly braces closed, and after curly braces we will write found at index, again dollar symbol, then curly braces, then result. So first of all we will save the file, and after that we will run the file using node and file name. We will see that element 7 found at index 6. We will check also, and 0, 1, 2, 3, 4, 5, 6. Yes, 7 is found at index 6. It shows that our algorithm is successfully working.